Hey there, just updating on GM Maker and the progress that I've been making on it and where I am at right now. So the first video was kind of more theoretical or kind of white papery documentation-esque, planning and that sort of stuff, and laying out tech specs and design and et cetera, et cetera. For this video, I'm going to show some initial implementation, which is exciting. So here's the project. Basically right here, all of these files in source, and yeah, I've got an initial map that's loaded from this custom JSON that I whipped up, and didn't want to use something existing because there's a lot of fluff in other JSON kind of map maker layouts and templates and etc. Like for example from tiled, I didn't want to use that, and yeah, so I'm just going for as minimal and simple and for making for what we need and not just making for, you know, what is out there in the wild. We can cross those bridges when we get to them. Also, aside from maps and loading in maps in a JSON format, we have music. These examples, they're all OGG. And then also sound. Here's some sound effects. And then here's some actual tiles, and these are the demo tiles we'll be using. These are actually 16 by 16. So if we go here, actually let's start here, pixel. So we have this kind of root pixel constant, and it's used all over the place. So if I look here, it's kind of scattered throughout. 16. So that's what I'm using for this demo. If I change this to 32, I am assuming that my tile sheets and etc. reflect a 32 by 32. So since I have a 16, it's 16 by 16. And these are 16 by 16. If I count them, so 1, 2, 3, and all the way, I can say, oh, I want to set this tile. So I'd be like, you know, X, I don't know, this is the 7th tile, so starting from 0, that would be index 6, and then Y, it's on the first row, so index 0. So we have that guy right here, 6 over 6 and down 0, and this legend says, oh, Q is that tile. QWE, that's the first 6, 7, and 8. So boom, boom, and boom. And then A, S, and D, these three, are 6, 7, and 8 also, but down 1. So that's not these top 3, but the middle 3, and then the last being Z, X, and C. These 3, same thing, 6, 7, and 8, but 2, so down 2. So that's those bottom 3. And if you look here, we have the Q, which is the corner, E is the corner, C is a corner, Z is a corner, W is the top middle, so I go WWW. S is the middle, and I throw that all throughout there. And then X is the bottom middle, and I throw that all throughout there. And then these are just the 4 corners right here. And then all this white space you see, all these spaces, they're literally just empty because they're not found in the legend. So therefore, they don't have. Yeah, I mean, in theory, these could be anything, but yeah. So this is a visually intuitive JSON mapping of what the map will kind of end up looking like, given this legend and given this tile sheet, which is right here, same name. So when I go ahead and load this guy up like this, and I have to switch this to game, which is the actual testing of the game. Boom. So if you pay close attention here, see Q, W, and then E, it kind of corresponds in the mapping of these tiles from the tile sheet to the actual background. I am using a canvas for this backing right here just for the tiles, but I want to keep like these little sprite blocks. So if I refresh, they are part of the physics engine, and I'll get into that in a sec. And yeah, these are created, these little boxes. So this is a 1 by 1, 1 by 1, and this one's like a 5 by 1 box. And one kind of represents the ground, and these are kind of like free or dynamic, or they're not fixed. So yeah, in this physics engine, call it create box, and it's as easy as this is. So if I go like this and I make a new box, Let me do 2, but then on 0, so I'll stack it. And if I hit refresh, boom. So we see, ooh, that's cool. So we added a new box there. So this is the gist of that. This physics engine is wrapping something under the hood. This physics engine is kind of like a wrapper that's specific for GM Maker. And under the hood, I am using Rapier. So Rapier is this, originally it's a physics engine written in Rust, the programming language. And the reason I chose it as opposed to like Matter.js or others, or like Box2D, but in JavaScript bindings, the reason I chose Rapier, aside from like, WebAssembly or WASM, and then Rust and blah 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 and all that, I actually chose it for determinism and serialization. And the reason I did that was because for this design, it's going to be very synchronizing heavy. So what I mean by that is like when, so it's part of this, the world state and the map state. So the map state, you're going to have kind of an initial, let's see, right here, you're going to have an initial state of things, and then there's going to be like a fast forwarding based on like both player input history, but then also like, let's say input, generated for NPCs and monsters. And then we'll take that initial state, fast forward it in our physics engine to the current time or the frame or whatever. And then eventually we will literally take a snapshot as described right here. Take snapshot. We'll take a snapshot, and then that snapshot will replace our initial state with our current state. So now our current state becomes our initial state. So we're swapping it out. So that way, like as we fast forward the physics engine from our new initial state, we kind of have these efficient steps, and also through those snapshots we can synchronize those across multiple players. So if multiple players connect to each other on the same map, and if I go back here, a player playing the game here, but then let's say someone opens Safari and they're on another computer entirely, and if they load the game, then in theory both this client right here, this player, and then this guy, they would be both loading the game. I think I'm having actually Safari WebAssembly support issue. Okay, no, never mind. This is good. But yeah, so this is the Safari version, and then this is some other player, and then this is another player, and they would both have the same initial state of the physics engine for this map, and then as one player like moves, both get updated, and then eventually the initial state for both is fast. It's replaced with the fast forwarded current state, and that's how we'll keep things synchronized and in real time and online across many different clients. And you have a ton of room for scalability with this design. You're really only limited by the weakest link of a front end that can have the longest living, rewindable and reusable physics engine state. So it's like if there are a million frames that, we can rewind all the way back to initial, fast forward a million frames. Depends on how quickly and efficiently you can do that with latency and stuff, and lag and things that are out of sync. And yeah, that the weakest link there, the weakest link is the one that determines kind of what we want to set that. Let's say like a synchronizing timer, like updating the initial state across all players on the one map, so that all of their physics engines are synchronized to a T on the same snapshot as described here. So that's the main reason why I'm using Rapier, and I'm using it can be 3D, but I'm using a 2D physics engine for this guy, because it just it makes the most sense for a lot of playability and pliability. being able to do whatever you want with this thing. So I'm creating these boxes, and then I have a stacked one there, and if I refresh, I just got rid of one. And it's as simple as putting one at 0, 0, 2, 1, and then another one at 0, 9, and then, oh, it's 5 width. This is this ground one here, and it's fixed. So that makes sense. It's not like, it's not affected by gravity. So, yeah, and then you can hear the music in the background, and if you listen, you hear a very soft or subtle, maybe you did, landing sound, and that was a collision. So here's the real-time frame stepping of both the physics engine right here, physics engine.step, and also the visuals. So we have this box, and this box. These are 3 divs right here. Actually, they all come from right here. Let's see. We can go down here. Box divs. These are literally the DOM div elements, and there's 3 box divs right now, and they have IDs that are rooted in. If we look up here, right here, they are rooted in whatever is returned. So the box ID. So that comes from the physics engine. And whatever handle ID that is, all of the divs have that guy. I'm rambling, by the way, but this is fun to talk about. And yeah, I just wanted to update anyone who is interested in seeing the progress of this thing. So this is a canvas background rendering all the tiles, and then these free, like floating, moving physics pieces, they're actually not canvases. They are divs, and we can just flat out render images on them and do whatever we want with them. And that's a big benefit to document object model, the whole DOM tree, and doing stuff with the DOM. And we're doing transforms and translates, which are efficient for the browser to do those, as opposed to like moving top and left. We just have that fixed, and they work kind of within the space, and then this ref, it gets moved around right here, style.transform, and we do a translate, and that's what you see right here. These are the real-time 60 frames a second translations of these divs. So I didn't want to go with a pure canvas-based thing because you can do a lot of stuff with the DOM, and it's got a lot of good stuff out of the box that you can tap into if you kind of balance both worlds. But using a canvas background for rendering all of these tiles and drawing them, that makes a lot of sense because that's kind of static, it's not moving. And yeah, we can worry about, like, let's say animated maps and stuff when we get there. That would just be kind of refreshing the canvas on an interval or whatever. But yeah, that's this in a nutshell, and this is the current progress made. Also, this guy resizes as needed. He's kind of a contain math equation based on the inner width and inner height of the browser window. So it is always resizing to be square. This black border you see can go away super easily. It's literally just, where is it? Right here. So if I get rid of that, and then I refresh, that goes away. So, and then that will allow us to set like a cool parallax background, or just a fixed background to represent for the map. And then, yeah, as you move along, the terrain and stuff will move, the camera will move, but the background will stay still, or the parallax will stay semi-still. And yeah, this is pretty good, pretty half-decent progress for this guy, and it's kind of coming together pretty nicely. So thank you for watching and checking out the update on GM Maker. I'm excited to continue making progress on this, and yeah, thanks again.